Hi, everybody. Very good morning. My name is Nidhi, and I am a mathematics educator. I have more than 5 years of experience, and in my experience, I have been in touch with a lot of students, and I have come across this myth, this perspective that they have towards mathematics, that even though they are good at it, they don't like it. And the reason that I have found out behind this thing is because they don't connect to the subject the way they connect to other things, other subjects like languages. They can see the use of languages in their daily life. They connect to it like a daily use thing. Other subjects also, if we talk about like sciences, physics, chemistry, geography, they can see around all the subjects around them, and then they connect to it in that way. They can see their applications, they can see the uses of those subjects around them. But for maths, they just think like that it's just any subject that they read in school, or maximum they use it as a tool in different subjects, in different streams they use it at. Okay, so I just wanted to change this perspective of students, how they perceive the subject mathematics. So that's why the topic I have here is mathematics demystified. And the big question I am going to tackle here today, I'll try to answer today is it a language or a tool? Because we perceive maths as a tool, as just some numbers there which help us in finding few things in physics or chemistry or counting the alphabets and all of that. We don't see it as specifically a language or a tool. So hence the big question, is it a language or a tool? Different questions we'll be answering, the small question to answer this big question. So we know mathematics is all around us, but what is it really? That's the big question. Is it a language? Is it a tool? Or can it be both? Yes, it can be for sure. So today we will explore this question in depth about this subject using different perspectives in our life. That is role of mathematics in our everyday life. Mathematics is a language of universe. This we have heard a lot of time, that mathematics is the language of universe. So if it is a language, why don't we perceive it like that? That is what we are going to discuss today. And also, how is it working as a tool in solving different problems? So let's dive into it. Just like any language, maths has its symbols, rules, and structure. If you look carefully, if you look at the basic things that we start learning about mathematics when we first were introduced to mathematics is the numbers. And they are what? Simply the symbols of this language that universe is trying to communicate with us. Different rules are there, that this is how we have the numbers in greater order. Two will always be greater than one, no matter in which corner of world we are there, right? So different symbols are there, different rules are there, certain structures are there, and they help us to describe different patterns, shapes, and relationships around us in nature. That's why we call it the language of universe as well as the universal language. The difference here is that in every corner of the world we have the same rules, the same symbols, the same numbers being used. No matter in which corner of world you are, wherever you are, 2 plus 2 will always be equal to 4, right? And the same numbers we'll be using there to define it. So it has been a universal language now. Some examples we can take is like different equations that we study. Okay, we don't know what the use of that is, but we see equations as how they describe how things are changing. For example, if I want to know that after a period of time, due to these n number of things, how is it going to change, then the equation tells us the relation between those unknown elements, and it will tell us how changing one of them will affect the other one. So this is how they tell us how things are working. If we talk about geometry, okay, another branch of mathematics, then it describes different shapes and space for us. That helps us in making so many scientific discoveries over there, and all the different streams of sciences are built on that. Statistics again describes trends and predictions. We have seen the financial market and different share stocks, all of that. That's all depends on statistics, and again that describes how it trends, how is it going to happen in future, what changes we can relate it to. Hence, given this is the let's say uh, bracket of different observations we have, that this is how it has happened and it'll how is it going to affect that in future. So these are all again the big things we are talking about, the implications, the applications that we are going to have. But if I talk about at the school level also, right, then I always share the story of numbers with my students, and that is very interesting. That is going to change your perspective about how we see numbers, how we perceive mathematics. That is, there is a reason why we have these numbers and what they are trying to tell us, why certain things are added lately in those numbers, and why we only had few numbers initially, right? If we go back in time, we started counting numbers, right? That means there was this reason that we need to count. That's why we have got certain numbers, right? And initially, we know we only had the numbers 1, 2, 3, 4, 5, and so on, right? Only the positive numbers. Just if I talk about the formal name of these numbers, that is natural numbers. We only had natural numbers because they were fulfilling a purpose for us. That is the purpose of counting. Hence, we call them counting numbers. And later on, we have got the formal name for different families of numbers. Then there were certain situations which arise later. That is, let's say I have a few number of things. Let's say I have 5 apples. I gave you all of them. Then what am I left with? Nothing. I can easily see that using this word nothing in English, right? But nothing was not there in mathematics. Then it was introduced later on. The discovery of zero was there. We say the big discovery. So zero is what? Just the representation of nothing in form of numbers, right? Nothing was introduced. Zero was introduced. So we added that also into the family of numbers that we already know. And we have got the another formal name for that. That is whole numbers, right? Which are different from what the numbers we already know. And there is a reason that why we have got that zero in there, because we wanted to introduce nothing in our language of mathematics. Then we define the nature, the relationship between the natural numbers and the whole numbers as well. That is how different families are connected to each other. That also we know. Now we know zero is the additional member in this family. So family grew bigger. So we can say the whole number family is bigger than the natural number family. And then again, certain situations were there where we had to represent opposite things. That is how to do that. For example, we in textbook, we see it like this, that we know how to write 3 minus 1, that is equal to 2. But how do we write 1 minus 3? Okay, how can we subtract a larger number from a smaller number? That is, we can see that these two differ by this quantity, but in which direction? Is it less by 2, or is it more by 2? Is the first quantity more than the second quantity by some number, or is it less than the second quantity by number? Hence, the difference is positive or negative. Now I have seen most of the time that when we have these positive and negative signs in front of numbers, students just start losing it there, right? But if we perceive it correctly, if we try to understand what these positive and negative signs are representing, then it will be very easy for us. For example, I just gave for subtraction that when we are subtracting a larger number from a smaller number, then the difference just tells us that the first number is smaller by this quantity than the second number. For example, if I say 1 minus 3 is equal to negative 2, that means first quantity is less than the second quantity by 2. So this negative sign is representing less here. Again, certain situations were there. For example, let's say we have two places having opposite temperatures. One is very hot and one is very cold. Until now, we only know the numbers 0, 1, 2, 3, 4, 5, and so on. So what is happening there? If we have to record the temperatures, then we are going to write, okay, at the first place, it is 32-degree hot. At the second place, it's 5-degree cold. It's 72-degree hot. It's negative numbers till we don't know. So let's say 5-degree cold. So in some calculations, some opposite things were there and some words were associated with numbers. Hot and cold, north and south, opposite directions were there, increase or decrease, debit or credit. Opposite things were associated, opposite words were associated with numbers, and they were making our calculations very messy. Okay, think of it how how harder it would become just simply finding the average temperature of 5 cities having some hot or cool temperature. So if I give you 32-degree hot, 25-degree hot, 5-degree cold, 55-degree hot, and 5 cities we have to find the average, but we don't know what to do with the words hot or cold, whether the result will be hot temperature or the cold temperature. So then the sign convention was introduced. That is, we represent simply the opposite things by the opposite signs. So positive is the opposite of negative, negative is the opposite of positive. Then we have certain words associated with these signs. For example, high temperature, increase, addition, credit, all these words would be associated with the positive sign. Opposites of those, decrease, less, down, these would be associated with the negative sign. So now that we have these sign conventions, we have given some more meaning to numbers. That is, now we had the numbers 1, 2, 3, 4, 5, and so on. Then the negative of those, the opposite of those appeared as well. And that also we have included in our family of numbers. I call them the family of numbers. So now the family grew even bigger. Now we have the positive numbers, we have the negative numbers, and we have the zero, the neutral sitting right in between them. So now they are representing opposite things for us as well. And the family grew even bigger, which we nowadays known as the family of integers. That is the formal name we give it. So from here, what we have understood is that these number helps us a lot in uh, understanding how things have happened and how we have included all of that in our language of mathematics as well. That is, this is not just a science or just a tool that magically the positive and negative sign appeared in front of numbers. No, there is a reason behind that. We wanted these numbers to represent certain things, some certain oppositeness. That's why we have given those sign conventions there. Now that we see numbers as the negative numbers as positive, opposite of positive numbers, now much less confusion is there. Now we understand how things work, what these signs are representing, and it makes us very easy for us to understand that. Now, this is not just an alien concept that there are some numbers which are negative. We don't know where they exist. We have never seen in our real life that, okay, there is some quantity which is negative 2. Negative 2 just means that it is less by that 2 quantity, by that number. So now that if we try to see it like this, it will be much easier for us. Right. Now that we have agreed upon that how we can use it as a language, let's see further more points that how we can see it around us also in our daily life. What are the applications? What are the different certain areas where we can see how it is helping us as a language? So first thing we can say is we know that it is called the language of universe because it helps us in explaining and understanding that is around us. For example, describing nature. Maths help us in understanding how things work in nature as well. For example, how planets are moving, how seasons are changing, how trees are growing. It helps us to describe all of these things, including like different applications we see in different subjects as well: force of gravity, speed of light. Different fundamental principles of nature are given to us, are known to us in the form of equations of mathematics. So, what are these equations? We can say these are just the language that nature uses to communicate its rules to us, that this certain value has to be there, then only certain things will happen, right? Gravity has to be 9.8, then only the life will exist here, right? If we want to send things in space, then they have to attain some velocity, some acceleration, then only they'll be going outside the atmosphere, right? So all these equations that we have, they are just the ways of nature trying to communicate with us, right? Different planets, trees, and all of these that things that we see. Next, we can say it is same everywhere. That's why we call it the universal language as well, not just the language of universe, universal language as well. For example, no matter in what corner of world we are there, the basics are always simple four operation: addition, subtraction, multiplication, and division, in which we deal with, and onto that we build everything. That is how things are increasing, how they can increase using addition. Addition is one type of increase, multiplication is another type of increase. That is, if we want to represent increase in what way, at what pace it is increasing or what pace it is decreasing. Same thing, it is represented by these simple basic operations, and that is same everywhere around the every corner of the world. Then mathematics also helps us in showing different patterns, how patterns are formed in nature. For example, the way a flower petal grows, snowflakes are shaped, these all can be explained using mathematics. The deeper we go, the higher studies we do in mathematics, we get to know these things called Fibonacci sequence, fractals, and all of that. And with that, we can explain so many pretty different patterns in nature and different things we see. So we all very fondly admire the nature. Right now, if we dig deeper into that, we'll be able to see that there are patterns, there are certain rules, certain patterns being followed everywhere, and maths will help us to understand that. And nowadays, like different engineers and infrastructure designers, they are learning from nature and replicating that to make different wonders of the world, right? Some things which are very unique and unique building styles or all of these things we are learning from nature and then applying there. Next, it helps us in predicting future also. Not the future we think of, but yeah, future in the sense that given a pattern, studying that, we can have some relation between different unknowns of that situation, and then we can predict how is it going to be in future. For example, very basic thing, when the sun is going to rise tomorrow, how far the rocket will go. Different scientific models are also based on mathematics. In recent example, if we see, there was COVID there, and mathematics again helped us in knowing that if this is the rate of increase, this is how people are getting affected, then there is a certain need of lockdown so that we can cut onto the spread of that. So all these are different models that we work in mathematics. That is how increasing things are going to happen, how they are going to affect 2 days after or 2 years after, given that certain conditions are there, how certain situations are related to each other. So using that also, different behaviors of everything can be understood and can be predicted using mathematics. Then in sciences, all obviously in all branch of sciences, the use is there. Starting from a small atom to giant stars, always maths helps us in understanding everything, be it physics, chemistry, biology, engineering, even social sciences. Maths is used as a tool there to calculate different things, for example, chemical reactions or modeling population growth, how population will be growth of whether people or bacteria or different diseases, how spread of diseases can be controlled, how far are they going to go. All of that we can understand using mathematics. So now that we have understood that, okay, it is a language, it is trying to communicate with us, it is trying to tell us how nature works around us using different equations, as we say, or different rules, different symbols, we can say that it also helps us in solving problems in different certain different aspects and different areas of life. From the ancient civilization to modern technology, we have seen maths has been a key tool of progress. So now that we have established it's a language, we can say it's a tool as well, that we all know, we'll all agree on that, because we have seen the applications everywhere. Genius use algebra and calculus to design different structures, economists use maths to predict market trends, doctors use statistics to access health outcomes. Now, not just engineers, economists, or doctors, the certain pros of their fields, in daily life also we all use math around us, if I tell you, right? For example, when we go shopping, different discounts we calculate there, we compare the prices, we manage the budgets, all of that we are using maths there, knowing or unknowingly, right? Different recipes, even inside our house, different recipes we are making, as our mothers used to tell us that, okay, certain quantity of water goes with certain quantity of rice, then only it will be cooked nicely. So it involves all the measurements and proportions in mathematics again there in cooking also. In time management, that is again very important aspect of life, calculating time, calculating speed, distance in our daily routines helps is helped by mathematics over there. Then in different games and sports also, we see how scores are working, what strategies we are using, different probabilities are involved there, again a very important part of life, and again important part of mathematics also, I would say, a different branch, which again helps us in knowing a lot of things around us. And finally, in technology also, we have seen maths power computers, phones, algorithms, everything we see there is based on mathematics. So in every day also, we see uses of mathematics around us. So again, if I ask you the big question, that is mathematics a language or a tool? Then of course, we can say it is actually both. It's not just the question of one of them, it is both. So it's a language that allows us to describe and understand the world around us, as well as it's a tool that helps us in problem solving. Excuse me. Now, it can be applied practically like a tool to fix a lot of things there. So we can say mathematics is both as a language, as a tool. It all depends on how we want to perceive it. So mathematics is all around us. At last, I can say it's not just something that we learn in school. To all the kids, I want to say it's not just something that we learn in school. It's with us every day. Ask the right questions and try to find yourself, how's it helping you, and why is it there, why certain things are there, and how it is helping us, then it will be easy to realize. Also, when we all the small and big examples we have seen here in shopping, in checking time management, playing sports, all of these applications we all see around us. And in nature also, we have seen different patterns, how science is helping us, and how we are seeing symmetry in different things. A pattern is being followed there. All of that can be explained using maths. And yeah, that is being followed, and that is how we are making a lot of scientific discoveries, designing buildings, bridges, or cars based on that, and it has made it more efficient for us as well. In short, I would like to say at the end that maths help us understand the world, make decisions, and problem solving, which is again a very big part of it. Whether we are counting, measuring, finding patterns, maths is truly around us and shaping everything that we do. And that was all, everyone. Thank you very much. I hope I was able to change your perspective on this, that how we perceive maths and how is it going to help us. And based on that, if any questions are there, most welcome.
Thanks, Miss Nidhi.
Yeah,
Wonderfully explained. If you can stop sharing your screen, the viewers
sure.
can have a better view of you. Thank you. So, Miss Nidhi, I don't see any audience, but I have received a couple of questions from the speakers on my WhatsApp. So I would be reading out the same to you. Most
Sure,
of the questions are already covered. If you would like to elaborate on some of the questions, you can.
sure, sure.
So, the first question is, can you share examples of how math solves real world problems?
Yeah, sure. For example, let's say very small, based for school students, I would like to say, okay,
Mhm.
just to help them out to see that, okay, they are actually applying things which they are seeing around them, which they are learning through mathematics. So they start learning simple operations and then they freak out when variables are there. Okay, like why these X, Y, and Z are entering into our lives in mathematics when we were happy with numbers, just doing direct calculations. So, very small example is, let's say they want to know that, okay, this is certain unknown quantity. And if we, let's say they have some pocket money, okay, and their mother gives them some additional money, let's say 20 rupees, and then they want to know whether they'll be able to purchase their wanted thing or not. They want to purchase a toy or something and they want to buy that or not. Then that unknown quantity we just represent by those alphabets which enter into mathematics and change everything. They are nothing but different things we use in place of blanks. For example, I have two unknown things and I put two blanks there. It would be very confusing for me to give an identification to that type of blank. So we just use alphabets there, and if we perceive it in that way, it will be easier for us. So in daily life also, around us, for kids also, in purchasing their favorite food, in buying their favorite bat, and buying their favorite toys, everywhere they can use mathematics.
Thank you. I think that answers the second question too. It is related to the reality of understanding. So you can skip if you want, or you can elaborate on this more. How does math shape our understanding of reality? You just gave an example, but like I think all these other questions I was going through, all you can give more examples on each
Yeah,
question.
yeah. So, as it, how is on this, how it shapes our understanding of the world around us is through how we perceive it. As I have said again, if we perceive it as language, then we see, okay, the nature is trying to communicate to us using mathematical equations and different symbols. And if we see it as a tool, then it is helping us in problem solving. The main thing is problem solving, how we measure things, how we calculate things, and how we take decisions based on that, because every decision that we take for future, how policies will be implemented, whether I want to buy a stock tomorrow or not, whether the disease will be can be stopped using certain measures or not, everything, all this decision making, maths try to help us. So the way it helps us in seeing things around us is how our today's decision is going to impact tomorrow. That is all what equations try to tell us. That is the relation between two things, one that we know and one that we don't know. So that is how math helps us.
Okay. So, Miss Nidhi, in your view, does math support or challenge the idea of free will?
Yeah, so for sure, it supports the idea of free will. It tells us, yes, how things depend on how things are related to each other. But yeah, if we go right in the right direction and if we perceive it in the right manner, for sure, it helps us in exerting our free will as well, and understand, like, it opens the gate to the infiniteness of the world, I would say, of the
Mhm.
universe, not just the world. And using that, going in that direction, even if you do a few wrong things, it will help you to learn that okay, certain things are not going right in that direction, not an open end things. For example, if I want to learn about certain thing, if I want to do certain things, open end things are there, right? That is, I don't know whether the impact or the consequences of this are going to be right or not, and it would take very long to make the right corrections and make it right so that it will be right to us. Maths helps us that okay, there are certain constraints over there, and just like an equation, again I'll take an example of equation, that it has a left hand side and a right hand side. If something is not getting right on the left hand side, it will never be equal to the right hand side. So that's why it helps us in keeping a check on that also, that how certain things are going to affect us. But yeah, it's not just confined to that. We can always add up few more things on which things are dependent on, and it will help us in exercising the free will over there.
There is a very, a short question, but a very
Yeah.
strong one. Is math truth absolute, is what someone is asking.
Okay, yes, yes, I would say for sure. Absolute truth. Going in the language side of it, there are no absolute truths. But yeah, if something is written in mathematical language, it will and for sure will be true, no matter in which corner of world we are there, because words can lie, numbers won't.
Yes, that's true.
Yeah.
The result matters at the end of the day.
Yeah.
Yes. So, ma'am, how does intuition relate to math?
Intuition. Okay. So, yeah, as we have taken the basic example of numbers, I would say. So, again, intuitions also works in whether something is right or wrong. Again, oppositeness, and that is very beautifully explained in mathematics. That is the base of how we use things. That, okay, in small example of science, I would take that on and off situation on which the computer is based, right? The binary digits 0 and 1, which are representing opposite things. That is just the flow of current when it's there and when it's not there. So intuition also works in same way, that how opposite things are helping us. And if we look upon it logically, and if we try to focus on in step by step using reasons, then obviously the logical thinking, which is the base for mathematics, will helps us in understanding where it is going with our intuition, or whether is it opposite of that. I mean, just to make it more clear, the clarity will for sure be given by when we think it like that, right or wrong, just the opposite things.
Okay.
Eventually, everything boils down to that.
Mhm. So, Miss Nidhi, how does math model human behavior?
Okay. Again, I will connect it with the last question only,
Right.
intuitions, right? All our actions, what we are going to do, how they are going to implicate, how they are going to result in, will be for sure can be learned through mathematics. Obviously, the decision making first, everything happens here, and then we do it, and then we see how it is going to be there. So yeah, in mind also, we can the intuitions and mathematics can help us in taking some decision, and in real life as well. For example, having a very small decision to make, that at what time we should wake up in the morning, or to a very big government policy, that how this much of budget is going to affect crores of people in our country. All these decisions can be taken using mathematics, understanding how things are working, making a timeline and all of that. So yeah, they indirectly or directly affect the decision making, and that in turn affect how we are going to work in future and what is going to happen there.
Mhm. So, ma'am, in your view, coming to the technical side, how does math impact AI development? AI is a big thing now.
Yes, yes. So AI is a big thing now, and as of now, also it's not like highly completely correct or functional, I would say. Again, it also we are just making the machine learn how to take decisions, right? And that is also based on certain inputs. That okay, if I ask the AI to generate a certain image to me and take certain decision for me, that now that I have asked you to generate an image, the machine has to decide what colors are to be taken, what actual shape is to be given there, and that is all based on whole research of all the data that is available, and all the data that is available online on which the machine is working. Just in layman language, I'm making you understand that okay, how this works. Then all the decision making that is done on the available data, and making the machine enabled to choose something which was not possible earlier. So it is again based on that, okay, I have seen 1 crore images online, 98% of them were black and white, so it will give us a result that is black and white. Again, numbers and the equation, the understanding is involved there, that okay, wherever the maximum thing is happening, then we have given machine the learning of that sort. Okay, the maximum or the more probability, you can take it to be right, and then rather than giving explicit input to it, it is learning on its own with the help of those mathematical inputs, that okay, I can make certain decisions here because that 90%, the more percentages of certain things, and this is that will help us in giving an output not based on explicit inputs of n numbers. So those inputs the machine taking itself is based on the mathematical decisions it's taking, because it understands only that. It doesn't understand the feelings or with what intent some content is put on the net. It only understands the numbers, the volumes, the quantities. So the base is whole maths again, whether it's the machine on which the AI is working or the software we are talking about. So yeah,
Yes.
it's making decisions based on the volumes of the data that is provided to that.
Yes, Ms. Nidhi will explain. So I think that covers this question's answer also. The question again related to the technicality, how does math secure online transactions? This is also a very, very important, aspect, right? So I think
Yeah,
you
yeah,
have
yeah,
in both the questions in one
yeah,
point. So, Ms. Nidhi, coming to the music, somebody wants to know how is math used in music? If you want to
yeah.
explain, you can explain. Otherwise, you can skip. Yeah,
No,
please.
sure, sure. As I have taken a small example called the fractals and Fibonacci sequences and all. So that explains us how different shapes are formed. Okay, just like that, different notes that are when we listen and good to our ear in only in a certain way. Again, we can explain that using mathematics. That is, this is the certain equation, certain harmony that is forming. A symmetry is there. Okay, whenever we talk about nature, we talk about symmetry, and symmetry can always be given by mathematics, whether something is okay. Different noises can be there. If we talk about musics, the basics are the basic tones. If I talk about the sa re ga ma pa, if I just keep on repeating just one of them, sa 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 sa, that won't be nice to our ear after a certain point of time, right? It will be irritating. Noises can be irritating as well, because they are in a certain pattern. That is why they sound good to us. And what patterns sound good to us and not to other, again, depends on how we perceive it. And that is again can be explained by mathematics, that how these patterns are forming and which patterns are good and which patterns are not that nice to our ears.
Mhm. You have spoken about infinity. What does infinity in math reveal about the universe?
Okay, again, I would say the limitlessness. Okay, we often confuse infinity by some value which is very large, but that's not the case. It just
Mhm.
represents something that cannot be explained. Obviously, there are certain in every aspect of life, in every different, I would say, different professions also, we always reach a point that okay, after this we don't know what to do. So that don't know what to do, but there are things that to be done, that limitlessness, that there is still a lot of scope, there is still limitless things that are to be identified, that can be worked upon, and that we can find out about, is what infinity represents. Not just a very large value, not just in numbers I talk about, in real life also. Infinity just tells us that there is limitlessness in our universe also. We just know a certain portion, a certain very small region of the space that we can imagine. And everything that is still unknown, still yet to be discovered, can be explained or can be represented in form that, okay, it's just infinite and we don't know.
Okay, ma'am. Last question, but not the least. What
Yeah.
future math breakthroughs would revolutionize our understanding?
Yeah, so yeah, I would say now that in our education, as from the basic, I will start that the education system, the way it's changing now, more and more uh, the visual and spatial ability that we are including in there with recent changes in textbook also, and changes in how we perceive things as well. Now that we have the use of AI, use of audio and visual aids are there, for sure it is going to bring a paradigm shift in how we perceive things and how mathematics is we are going to see in near future. That it's not just some tool, just some subject that has been taught in school, which is very difficult and we didn't know, or the basic implication is just to add or subtract things in our daily life. No, we are going to change that. We for sure will be seeing very soon in future that how we use it as a language, how we use it to understand more than just the basic things. Just like application of any language that we see or any other subject that we see around, we are going to see that through for mathematics as well, not just as a tool or as a use or a secondary thing, I would say. Always used to perceive it as a secondary thing, that okay, we read physics, mathematics is used there. We know these many alphabets, okay, mathematics is being used there. No, it itself is a very big branch, a very big region to explore, where we can see so many aspects of this subject, and direct use also, indirect uses also in other spheres of life we are going to see. And for sure we are going to change, mostly I would say, the way of learning it and the way of perceiving it, for sure.
Mhm. Thank you, Miss Nidhi. Thank you for the talk
Yeah.
and for patiently answering all the questions in detail, especially. We also thank the audience who has sent the questions to me, though they couldn't directly attend the session. They have posted the questions in my WhatsApp. So before I end the session, would you want to mention anything else, ma'am?
No, that's it. It was very nice to be here, and it was a very nice session, and thank you very much for having me.
Thank you. I'll stop the recording.